Okay, so let's hope we're getting close to the end of the recordings on the discussion topic for this week. We have, to recap our situation, we are trying to find the solution to having invested in two accounts, two investment accounts, which provide different interest rates, and the idea is to try and find how much to invest in each account so that we get a return of $7,000 per year when we have a total of $100,000 to invest. So we come back to this equation. And actually, I'm going to go to the other graph here, which I wrote out for you already. These are our two constraints, right? Now, note here, just for the sake of not having to scroll in and out and zoom a whole lot, I'm just going to convert the thousands into kilobucks, if you will, the thousands of dollars. So, I forgot, Blondie and Doug would have $100,000 or 100 kilobucks, right, to invest in the two accounts. So you can just think of it in that. Think of, $1,000 bills, and they got 100 of those. Okay, so their total quantity that they want to invest, Blondie and Dagwood, is $100,000. I'm simply going to write it as 100 kilobucks here, right? And then the return that they want is they want to get $7,000 or 7 kilobucks back per year, right? And here is that. So this one was our first constraint, which is on the amount of money that they can invest. And this is our second constraint, which is the amount of money they want to earn as a result of their investment. We have been given the interest rates. The savings account has an interest rate of 3% per year, which is 0.03 per year, right? Remember our discussion about the units? This is going to multiply the dollars here. And the interest rate on the mutual fund was 10% per year, or 0.1 per year, which is going to multiply the investment put into or deposited into the mutual fund to give us then the return, which is 7,007 kilobucks per year. So far, so good. Make sure you write this down as a sentence or as an equation to make sure that you understand this. Okay, I'm going to pause for a little bit here. Okay, so I hope you did write down your understanding of the situation. It's good to keep repeating and reiterating this thing to make sure that the understanding is firmly embedded in your head here. Okay, so we have two unknowns. Remember, the amount of money we want to invest in the high yield savings account and the amount of money that we want to invest in the mutual funds. And in order to solve for two unknowns, we need two equations, and we get the two equations that we need in the form of constraints. The first constraint being the amount of money that Blondie and Dagwood could invest. The second constraint being the amount of money they want to earn upon that investment. And remember, we have sort of ignored the time dimension of this. We're just assuming that everything is taking place in 1 year. So our first constraint is X is the amount of money to be invested in the savings account. Y is the amount of money to be invested in the mutual fund. All right, so we've got these two equations. I'm going to turn this one on. And the reason we don't see it is because, I was zoomed out or in too much, rather, right? Imagine if this I've written that I was at $100,000, how much zooming out we would have to do in order to be able to see the equation. Okay, anyway, the equation is very simple to understand. If your total amount of money, which you have partitioned into two piles, is 100 kilobucks, $100,000, well, you can have all of the money in one pile, which is down here, right? Or all of the money in the other pile, or sort of half and half, which is here, and so forth. That is why this line is running from 100 on the y-axis to 100 on the x-axis. Ideally, this should be a square. The reason it doesn't look like a square is because the way the graphics are being plotted on the screen, it just changes the aspect ratio, okay? But pay attention to these numbers along the dimension, along the axes. 100 units here, 100 units here. The units are, in this case, exactly the same. They're dollars. I guess, put a label, dollars in savings account, right? And this one is Y, right? Dollars in mutual fund, okay? And just click back here and voila, it's in here. So dollars and dollars along both axes. You want to be careful about this, right? And I should say, let me go back and actually do this again. This is kilo dollars, right? Because we're talking about kilobucks. Okay, kilo dollars, right? So 100 kilo dollars, 100,000, and so on and so forth. Now I'm going to turn on the second equation, right? And here's my constraint. And look, this is kind of beautiful, isn't it? I turn on that equation. It's return of $7,000, 7 kilobucks, interest rate of 0.03, 0.1, and hey, here's my solution, right? Yeah, I'll put the cursor there. It's right here. X value is 42.857 kilobucks. Y value is 57.143 kilobucks. And, that's it. That's it. That's the answer. That's what we were looking for. I put in this much money, the 42,000, into the savings account and the 57,000 into the mutual fund, and lo and behold, Blondie and Doug will get back 7,000 a year. Now, just to round things up, I'm going to make this 7,200, right? Which makes it nice and easy, because the solution is now, hey, put $40,000 or 40 kilobucks in your savings account, 60 kilobucks in your mutual fund account, and away you go, right? I'm just going to make this a small U. That's it. That's the answer, right? Remember, we started with the problem. What was the problem? The problem was that Blondie and Dagwood had $100,000, 100 kilobucks, that they wanted to invest into two separate accounts. One, they wanted to play it safe and get an insured account with a high interest rate, and that was the FDIC insured high yield savings account. And then the second one, they were willing to take a little bit more risk, not a hell of a lot of risk, because, well, it's a mutual fund is not all that risky, seriously, but it is still not guaranteed. You could lose all your money in a mutual fund. So they were just being cautious, but they still wanted a pretty high amount to be earned from their investments. So the idea was, okay, we take this $100,000, we partition it between a high yield savings account and a mutual fund, which gives a higher interest rate than savings account because it's riskier anyway. And then we get the $7,000 or 7,200 in my rounded up figures here that Blondie and Dagwood could earn per year. So we plotted the two equations, combining the two variables. Each equation had two variables in it: the amount that they put in the savings account and the amount that they put in the mutual fund. So each equation, the amount they put in the one and the amount that they put in the other are the two unknowns. So in order to solve for two unknowns, we need two equations. And we got the two equations by using the two constraints that we found in our description of the problem. They didn't come from nowhere. They came from the description of the problem. The first one was Blondie and Dagwood only had $100,000 to invest. So that gave us our first constraint. So if they took their money, that 100K, and partitioned it into two lumps, one to go into the mutual funds and the other to go into the savings, that gives us our two unknowns: how much to go in the mutual funds and how much to go into the savings. And the constraint is, well, the two together must add up to their total savings that they had collected in their mattress, maybe, I don't know, $100,000. And then our second equation, involving again the amount to be put into the savings account and the amount to be put into the mutual fund, came from the second constraint that Blondie and Dagwood had specified, which is, hey, we must earn at least $7,000 per year, right? And so that gave us this equation where, again, this X, right, are the same. The amount of money put into the savings account and this Y are the same. The amount of money put into the mutual fund. And S is the interest rate on the savings account down here, 0.03, and the interest rate on the mutual fund M down here is 0.10. Now, having written the equations and having found the solution, there's a lot of leeway here in terms of figuring out what's going on, because note the use of these sliders. Let's leave the 100K fixed where it is for now. But let's say if Blondie and Dagwood want more than $7,000, okay? So they move the slider over here. Now look at the point of intersection. Okay, what has happened over here? The X value has decreased to 20.7 and the Y value has increased to about 79.3 almost. The Y value being the amount you put in the mutual fund. Yeah, that kind of makes sense. The mutual fund has a higher return, so it gives you back more money. And so you put a larger proportion of the money into the mutual fund and a smaller proportion into the savings account, which has a lower interest rate, right? But of course, it's riskier. So one of the things that is recommended is that as you get older, you make your investments less risky, because if you need to cash it in for some reason, you don't want to be caught with the market at a low point, right? That would be really bad because you'll be losing money. So let's get into the time travel machine and assume that Blondie and Dagwood have aged. I don't know. In the comic strip, they must be approaching 80 or 90 now. But anyway, okay. So they want to lower the risk. Okay. So they're willing to live with a lower interest rate on the mutual fund. But look what's happening over here. The solution now is way out here. It's in the negative 38.75. They're gonna what? That doesn't even make any sense, right? The plus was when we were putting money into the savings account. A negative here means we're taking money out of the savings account. We're taking out 38,000 kilobucks or 38 kilobucks. Makes no sense, right? This is showing you here is that your two equations do have a solution, but this is not a physically viable solution, right? You cannot apply this solution in the real world. In order to apply or to find a solution in the real world, it must lie in this quadrant where both X and Y, the amount of money put into the savings account and the amount of money taken out or put into the mutual fund, happen to be positive numbers, right? Negative numbers don't make sense here unless you take out a loan, which just changes the whole picture. I mean, so don't go there right now. I mean, we haven't covered enough material to be able to deal with that. So basically, you can tell Blondie and Dagwood, like, hey, this is not going to work. If you want such a high rate of return, you're going to have to take on a riskier investment, or you can live with a lower rate of return. And so if we move D down, well, okay, we are in a physically viable region of the solution. Okay, so here what you can do is, if you're willing to live with $6,500, put 12 in the savings and 87 or 88 almost in the mutual fund. If you want, if you want an even lower risk thing, then you kind of, you're gonna have to live with a lower return, right? Or if you want, you're just going to have to live with the lower return. If you want a little bit higher return, you could do this, and 5% return is still pretty decent, right? But it's a little bit safer because now you've got the amount invested in the savings account is larger. It's about 2/3 of your money is going into the savings account, and only 1/3 is going into the a little bit riskier investment. Anyway, so we started out trying to figure out what good these straight lines and simultaneous equations are for, and we figured out that a straight line can be used to represent the return on an investment. Then we figured out, okay, if we have two investments which have different interest rates, and we choose to represent each with a straight line, how do we figure out how to partition our total amount that we want to invest between the two types of investments so that we can earn a certain amount of return per year, right? And in order to do that, we combine the equations associated with these investments into each account, right? We added them together to give us our first constraint, which just happened to be also our first constraint, which was the total amount we wanted to invest. And because we have two unknowns, the amount to put into the savings account and to put into the mutual fund, we need a second equation. And the second equation we found came from our second constraint, which was, hey, I need to earn this much money per year. And so if the interest rates and the respective accounts are as given, that gives us our second equation. So now having two equations, each of which comprises two variables, x and y, right? And those are our two unknowns, but we do have two equations and two unknowns. We can then solve the equations to find answers for both x and y. Okay, I haven't here proved that you need two equations for two unknowns in order to be able to find the values of those unknowns, but I don't think you really are interested in that right now, and this is plenty, right? So good luck. What I want you to do, this is important, what I want you to do is I want you to go back and rewrite the problems that you conceived or created, because I noticed, well, you know, that you had so many terms on one side and the units didn't balance, and there were too many unknowns, and some of the problems could have just been solved with one variable and one unknown. Okay, so go back and think about it. I hope this was useful. Lectures have become a little bit verbose, so just speed them up to get past and go through them quickly. And you can pause the pieces that are or slow down the pieces that are of interest to you. All right? Have a good weekend.